Včera chcel písať, čo CSV a vyšlo, že Príjemný dobrý večer. Trošku meškám, začali by sme. Adam Miskiewicz pripravený. Vďaka IBM máme dneska tento večer nachystaný. Po skončení, po diskuzii ešte vás pozývame 2-2. Oproti niekedy poznáte tento bar. Vidíte, to je? Mimo na nás. A teším sa na našu prezentáciu. Otázky po skončení. Prezentácia bude v angličtine. And the floor is yours. Oh, maybe yours.
Ja by som chcel dobrý večer. Ja som Dano. Som dobrý. Prosím? Bol prekvapený, že tak dobre rozumieš. Môžeš na... z Bratislavy. Bratislavský dialekt. Som veľmi rád, že vás sem toľko prišlo šikovných mladých ľudí. Nevidím tu veľa dievčat. Keby niekto chcel, tak myslím, že môžeme oddať niekoho počas tohoto obradu, čo je celkom pamätné miesto. Šťastný tí z vás, ktorí sú slobodní. Ja som z firmy IBM a som veľmi rád, že sa nám podarilo túto akciu v Košiciach zorganizovať. Chcel by som sa poďakovať Reactivu, firme, ktorú určite poznáte, šikovnej reaktovej konferencii a bratislavskej koderskej firme. Chcel by som sa poďakovať distribútorovi za tento priestor a určite excelentnému speakerovi, ktorý bude rozprávať. A teším sa na to, že sa všetci dozvieme niečo zaujímavé o veciach, ktoré dneska hýbu svetom, ako sú mobilné, javascriptové, cloudové asi nie, ale proste sexy témy, ktoré riešite vy a ktoré riešime my, takže prajem vám veľa zážitkov, veľa zaujímavých vecí a potom snáď nejaké to pivko si dáme spolu. Takže díky a príjemný zážitok.
Testing. There we go. Trip on that. Okay. How's it going, everyone? I'm going to speak in English. So, hopefully that's okay. This doesn't work. So, building native mobile apps in pure JavaScript. That's what I'm going to talk about tonight. Thank you for the introduction. I'm really happy to be here. I've never been to this part of the world before, so it's been kind of a fun trip so far. Yeah, excited. So, my name is Adam Miskiewicz. I'm a software engineer at a company called Exponent. That's my Twitter handle if anyone wants to follow me. And at Exponent, we're building a mobile development platform that lets developers write fully native cross-platform mobile applications in just JavaScript. So tonight I'm going to talk a bit about React Native, what Exponent is and what it offers on top of React Native, and why building mobile applications in JavaScript is just very cool and has a lot of interesting possibilities. So I want to start with why, because I think that's important. So how many of you in this room have built a mobile app before at all? Okay, lots of you, great. So what type of technologies have you used? Was it like a web technology like PhoneGap or Ionic? Raise your hand if any of those ring a bell. Yeah, PhoneGap, Ionic, okay, all right. Cool, and then what about fully natively? Okay, all right. So that's a good audience. So I guess I'm here to convince you all. I have a pretty wide-ranging development background. Oh, by the way, I'm sorry about this. I don't know why my computer keeps doing this, but I don't know how to fix it. So a pretty wide-ranging development background, but in a former life, I've kind of done quite a bit of fully native iOS development in Objective-C and Swift. So I do speak from a bit of experience, so hopefully I can relate to you guys on that. So why do we develop apps natively in the first place? Well, I guess that's the tools that Apple and Google give us, but when it really comes down to it, developing applications in a native compiled language, like Objective-C, Swift, Java, I mean, it gives you just a ton of power. There's virtually no limit to what you can do given enough time and effort. And obviously, you can drop down to C++ on both iOS and Android if you really need certain things. So there's just tons of power there. But I would argue for the sake of this conversation that we'll have tonight that probably 90% of applications maybe don't need that raw access to power, right? There definitely are some that do, but I would argue that most don't. So I think that developing a native app, even though you get this power, it's not always the best developer experience, despite any of these perk benefits that you might achieve. And so you have Xcode and you have Android Studio, and they're pretty good modern tools. They keep getting better every release. But I want to take a second and compare mobile development to web development. How many of you are web developers? Okay, cool. So modern web development is kind of interesting these days. Many of us may talk about JavaScript fatigue, and that's kind of plaguing modern web dev these days. But I think there are many really awesome things about the developer experience of web development that you just usually don't get with native web or native mobile development. So what are some of these? So first of all, when you're doing native mobile development, you have the opportunity to use interface builder if you're building on iOS, or there's equivalent things for Android built into Android Studio. But those usually only get you so far, and most people that I know, including myself, who have done native mobile development before, eventually eschew interface builder and drop down to writing layout code in Java or Objective-C, and I don't know. CSS is pretty bad, but writing layout code in Objective-C or Java is definitely not a fun thing. It's not fun in general, but it's definitely not fun from how much time it takes, right? From that type of point. And so that leads me to my next point, which is that with native mobile development, when we want to test any change, we have to recompile that entire app, right? There's no concept of live reloading or hot reloading we're getting in web development these days. And as time goes on and your app gets bigger, those compile times are only getting longer and longer and longer, right? It almost goes up linearly to a point. And that can really negatively affect app iteration times. App iteration time is super important when we're talking about building, especially a new product, right? We want to build it fast. We want to get it out to users, and so it's not very easy when you're doing native mobile development to deploy code quickly. You have to wait for App Store review times, and they have gone down. I'll give Apple that. That's a good thing. But even in the case of something like the Google Play Store, you could submit your app and it could still be several hours before it got into the store for people to download. And then, and this is something that people don't often take into account, you can't assume that as soon as you release an update that your users are going to get that update right away, right? I mean, I think my mother has never updated an app in her entire life. So like, she's probably still using like a 2-year-old version of Facebook that Facebook still would like need to support, right? So you have no real guarantee, even though you can hope that people use automatic updates. You don't know that they're going to do that. So that makes it really difficult, I think, to get feedback from your users quickly, right? And what if you wanted to perform something like an A/B test, right? I mean, don't get me wrong, there are some native A/B testing frameworks, but they're usually quite limited in what you want to do, and or they drop down to like using a web view or something so that you can like easily insert different content. And I don't know, I think that potentially is a subpar experience. And then I want to just ask quickly, what's the opinion of React in this room? Do you guys like React? Yes? Okay. Did I hear a no? Okay. That's okay. So, like, I love React, and one thing that you don't get when you develop a native mobile app is React. And when I've done a fair amount of web development, and like it's like really hard to go away from React after using React for a long time and not use it anymore. For what it's worth, I mean, there are some native React-like type things, such as Component Kit, which is also built by Facebook, that lets you have a React-like programming model, but it's in Objective-C. However, like even with something like that, which is arguably really fantastic, it's you're still going to run into some of the other problems that we talked about, right? So I can complain about native all night long, but the fact of the matter is we need it, right? Like there's a reason why we're developing native mobile applications and not just like making everything a website, right? Like so what we want is like that fantastic look and feel that we're used to when we develop natively. We want access to native components and gesture systems. And I kind of have this philosophy that generally, like, it should be much more important that your user is having a good experience than whether or not you are having a good experience as a developer, right? Like, that might be hard to admit, but I think, like, if you're working quickly and, like, iterating fast, but you're delivering a really subpar user experience, that's probably not a good thing. Your users are probably losing in that case. And so, kind of speaking of that, like Cordova and PhoneGap and Ionic, I have to say, like these frameworks are pretty neat. They've done a really great job implementing like native-like components in web views. These solutions both use web views. And that gives some of that fast iteration speed, but they still don't quite feel native. And I would argue that if you see an app that is built in Ionic, Cordova, or PhoneGap, there's probably something just a little bit off with it when it comes to user experience. And then on a more technical level that isn't just user experience, using a web view type of solution doesn't give us access to kind of a more sophisticated threading model. Which means that like we're limited in many ways in the power that we can get from these powerful phones that we carry in our pockets, right? Like the Nexus 5X up here has like 4 cores and like a bunch of RAM, and the iPhone 7 Plus is actually like faster in single core performance than this laptop that I have sitting here, which is pretty crazy. We want to be able to take advantage of the power in these phones. And so say you wanted to do image processing or text measurement, which you use for layout. Like we need more power than what a traditional single-threaded JavaScript implementation provides. Okay, so how many of you are familiar with React Native? Ooh, not very many. Ooh, this is good. Okay. And have you used React Native? The guy that raised his hand back? Yeah, like have you deployed an app to production with it? Or just played around with it?
Play around.
Gotcha. Cool. Okay. So, all All right, this is fun. Okay. So for those of you that don't know what React Native is, it's a framework from Facebook that allows, or that attempts to solve many of the problems, or maybe all of the problems, that we just talked about with native mobile development. All right, so let's talk a little bit about how it works. So you're going to take JavaScript, okay, and if you're familiar with React, right, you're going to render some React components. You're going to render a view, you're going to render image, you're going to render text, or lay on Android, or an iOS slider, right? In this case, this JavaScript is not going to get executed in any type of web view, which is a really important distinction from a framework like Cordova or Ionic or PhoneGap, right? All JavaScript runs in a JSVM, in this case it's called JavaScript Core. So in iOS, JavaScript Core is built into the operating system. It's actually what powers the Safari browser. And with Android, we include a copy of JavaScript Core in the binary that you ship to the App Store. And so JavaScript Core is like this really fast, powerful JavaScript VM that's very similar to V8, if you're familiar, which is what powers Chrome and Node. So basically, when you execute this JavaScript, React Native is going to do some funky stuff, and it's going to build a JSON message that is describing a certain action, and it's going to send that over a native asynchronous bridge that's written in C++, which I'll expand upon a little bit in a minute. And so when the native side receives this message, it's going to actually take that message and create a view, right? It's going to create an actual UI view or an actual Android.view instance. It is not rendering anything in a web view. And so going back the other way, when a touch event occurs, a message is going to be sent from the native side back over the bridge that you can then process and respond to in the JavaScript layer of the application, right? So I think I want to take a second and expand upon the React Native threading model, because I had mentioned that before, that in a traditional WebView application you wouldn't get any access to any more threads than just one. So when you call a function in JavaScript in React Native, it may be intuitive to think that when render is called in my React component, that it's immediately going over that bridge and rendering those components. But if we did this, if we executed these things synchronously, we could really easily cause the main UI thread to be blocked by the JavaScript thread, which could cause drop frames and generally a bad user experience. In addition, because we're marshalling JSON between JavaScript and native, there could be a pretty significant cost, depending on how big these JSON messages are, to keep serializing and deserializing these messages. And so we went across the bridge on every JavaScript call. We'd incur probably tons of overhead. So, the solution to this problem that the smart engineers behind React Native came up with is to use an asynchronous bridge instead of a synchronous one. So that means we're able to take these calls that do native things, such as create views. We can batch them together before they get sent across the bridge into native land. So basically, React Native will take these calls and batch up as many of them as it can per frame, so per 16.67 milliseconds, and minimize the cross-thread communication overhead. So in order to do this, though, you need some type of programming model to support, being declarative and allowing you to define your views up front and then send those across the bridge. And so that may seem familiar to you guys. It's React, right? It's a declarative programming model, and it allows us to define our views based on props and based on state, and we can intelligently batch those JavaScript calls that create UI in a smart, thread-safe, and really fast manner. So Oh, one other thing I wanted to say about the threads is that there isn't just two threads in a JavaScript or in a React Native application. There isn't just the main thread, and which is the UI thread, and the JavaScript thread. We also can take advantage of doing complex things like layout, which React Native has its own layout engine powered by Flexbox. All that work can happen on a separate thread. So there's a lot of opportunity there. And if we ever had another use case for more threads, we could just add those and build that up. So I think when I talk to most people about React Native and they hear how it works, at least, I mean, it's definitely correct to, of course, be skeptical, but most of the time the initial feeling that I get from people is that they're excited about it. You have this opportunity to write JavaScript, but actually still get a performant mobile application that uses fully native views. So React Native's architecture is pretty sound. And it comes with these building blocks that we need to create mobile applications. But how can we take this further, right? And provide a really good out-of-the-box experience and really take the philosophy of write your mobile app in just JavaScript to the extreme. Just as a quick side note, vanilla React Native, just normal React Native without anything layered on top of it, does let you, kind of drop down to native land if you need to, right? You can build out native modules and communicate and expose a JavaScript interface to them, et cetera, which is very cool. But what I want to talk about tonight is actually not doing that and just writing it in JavaScript as an app developer. So that brings me to Exponent. I'm going to use Exponent as an example throughout the rest of this presentation, given that it's the platform that I'm most familiar with because I work there. But I do want to stress that these approaches that I'm going to talk about that Exponent takes really could be utilized in a typical React Native, albeit with a bunch of work. So if you had an engineering team that couldn't use Exponent to help you with this stuff, you could theoretically take the same type of ideas and implement them yourself. So what is Exponent? I think the best way I can communicate what Exponent is in a one-line way is that Exponent is like Ruby on Rails for React Native. And I probably shouldn't have bastardized that logo, but oh well, somebody can sue me. So of course, if you know Ruby, given enough time and effort, you could replace Rails, right? Or at least for your own use case, right? You could write the components that you might need for your application yourself, or you could pull the necessary pieces from the open source world and piece together your own framework. But I want to think why do people use Ruby on Rails in the first place, or things like it, right? They use it because they want to get started quickly, have a framework that can grow with them as they continue building their application, and it provides this stable platform that they can constantly rely on. So in a nutshell, that's what Exponent is trying to deliver to the world of React Native. And obviously, since we're building on top of React Native, I mean, we love React Native, but I want to stress that that React Native is built by Facebook, mostly. I mean, there's a lot of community involvement, but mostly built by Facebook and for Facebook. Which means that the team who works on React Native at Facebook, their first priority, and I can't say it's their only priority because they do care a lot about community, but their first priority is going to be working on React Native and improving it for Facebook's needs. And this is okay, I mean, for them, it's okay. But some of the things that Exponent offers to React Native and to the React Native experience may not be useful for Facebook, but hopefully can start to be useful to make React Native more useful for the rest of the world. So, okay, so what do you get when you start a vanilla React Native app? Okay, so by vanilla I just mean something that isn't using Exponent or anything like it. And so what you do is you npm install React Native and wait probably 4 hours for npm install to complete because npm is the slowest thing ever. And you type React Native init, And what that's going to do is create an Android Studio project and an Xcode project. But if you're not on a Mac, you immediately have a problem. To do iOS development at all, you need a Mac. If you want to compile anything in Xcode, Xcode doesn't run anywhere but a Mac. If you want to use the iOS simulator, there's no other option. So you have to have a Mac. So that excludes, a large portion of the population. Even though I love Macs. Say you do have a Mac. Okay, so to compile and run and test this app that it initialized for you, you're going to have to open Xcode or Android Studio or use some command line toolchain from either of those products, in addition to starting the React Native Packager server. And if you want to change any settings for your app, say like add fonts or change your version or change the loading screen icon or anything like that, you're going to have to, on iOS, you're going to have to edit like an info.plist file, or on Android, you're going to have to do some crazy things in the Android XML files. And so I think you can understand that, especially if you're a beginner in native development, right? And so say you come from web development and never built a native app before, you're immediately kind of getting thrown to the deep end by having to at least kind of start to understand Xcode and Android Studio right away. And that can be daunting for people, and at the very least can just slow down the kind of startup time for getting onboarded to React Native. So what we've done with Exponent is try to make that really easy. So you download this tool, you create a new project. It's going to automatically start the React Native Packager. And here we're opening the iOS and Android simulators, and there you have an app. It's done. For what it's worth, that doesn't include npm install time. That was a bit sped up. But generally, if you took out npm install from the whole process, you'd be up and running in like 30 seconds. And I do want to stress here that you can see that this Welcome to Exponent little sample app here is living in this other app, this Exponent client, which I'll talk a little bit more about in a bit. But you don't have to have Xcode or Android Studio even installed on your machine, because you could download the Exponent client on your phone, and man, that's annoying. Wish that would stop. Exponent client on your phone, and simply hit this URL that's going to appear up there, and it will automatically start the app on your phone. You don't need to develop on a simulator. Obviously, it's a nice thing, so if you have a Mac building an iOS app, it can be still useful to use the iOS simulator, but you're not required to. So that link right there is kind of a special link. It's actually tunneling directly to your machine, so that it can open the JavaScript that's being hosted by your machine. And that means that you can send, as long as your laptop is open or your computer is turned on, you can send that link to anybody, no matter where they are in the world, and they can remotely view your app. So say you wanted to share, as you're developing, share your app with a designer on your team or a friend or a family member. You can just have them download the Exponent client from the App Store, send them that link in a text message, and open it up. And then, of course, obviously you're going to want to be able to have people use your app when you close your laptop. So you'll just hit the publish button up there, and that's going to publish up to our CDN, and anyone can hit that. It'll give you a nice, friendly URL that you can share, and anyone can hit that and open your app in the Exponent client. So I want to take a minute and talk about this feature, because I think this concept of write some JavaScript and then be able to send a link that opens a mobile app with native views and everything with just a URL is a pretty important part of Exponent, and one of the best parts about building a native mobile app in pure JavaScript. So when you're constraining yourself to only writing in JavaScript, it opens up this extremely exciting opportunity, which is that you can publish your JavaScript to this remote location, and you can perform fully over-the-air updates of your native mobile application without constantly going through App Store approval. That's a pretty cool thing. And I get questions all the time about like, well, how does Apple allow this? And in fact, Apple explicitly allows this, and the key here is that it allows you to run code that is remote code that is downloaded and run by either Apple's built-in WebKit framework, which we're not using here, or JavaScript core, which we are using, right? And that's not something that they added at the beginning of time and they just had like forgotten about and are going to take it out every day. That was actually added just a couple of years ago, not too long before React Native came out in the first place. And so I think the chances are, while I can't like speak for Apple, I think the chances are pretty good that as long as people aren't continuously abusing this, that they'll keep this around. So this ends up being pretty powerful. So for those of us that come from a web development background, we're already used to this type of functionality in the first place, right? Like remember back in the FTP days, you could just like hit save, and your app or whatever you were building would just be live on the internet immediately. Obviously now it's a bit more of a process than that, but generally, we're giving that same type of experience to mobile development. We can bring that web-like publishing functionality. Okay, so all right, so I talked about publishing stuff. Now what does it look like to actually like build something? So let's pick a feature. So you started building your app, you show it to your designer or your product manager, and they come to us as a developer and say, we really need to be able to display videos in this news feed, this fictional news feed of our application, right? Okay, you say, no problem, it's React Native, should be easy. I'll just go find some video solution. So, well, when you go like run and do that Google search, you're gonna get a big list of probably several different React Native video libraries. You'll eventually decide on one, and then you'll have to figure out how to link it into your application. To React Native's credit, they've done a really good job with this. You can just type React Native link and give it a URL, and it will automatically download the Android and iOS dependencies and get it into your app. So that's great, you're done, right? Well, you find out soon after that React Native releases new versions, potentially and often breaking versions every 2 weeks, which means that the copy of React Native video that you just installed doesn't work anymore. So what can you do? You can fix it. Okay, that's one option, but that takes a lot of time. So what we're trying to do with Exponent is build these things in, right? So that's my dog there running around. I miss him. He's pretty cute. So that's the video component. You can see briefly that we have a lot of other components here. So all you have to do is just import components from Exponent in your JavaScript and use the components.video component, and you're off to the races. So why does this work? I thought you said we're only doing JavaScript stuff. So the reason that this can work is because we're bundling a bunch of native code with Exponent, and we bridge that functionality to JavaScript. And we're continuously expanding those APIs and SDKs that we support. But again, the general idea here is that as maybe we're doing native development, like at Exponent, or maybe if you're contributing to Exponent, you're doing some native development. But as an app developer, you're writing your app in pure JavaScript. And then, secondly, the reason that we don't have to worry about that React Native versioning issue that I was talking about with Exponent is because we have something called native runtime versioning. And what this means is that we're able to include several different versions of both React Native and the Exponent SDK, which is what contains our native modules like video and such, into both our client app as well as the standalone app that you build with Exponent. And so based on the SDK version that is set in your project configuration, as soon as a user hits your app on the Exponent client, we can automatically load the correct runtime. So when you're ready to finally upgrade to the next SDK version or whatever, you can do so, and you can do so. We really strive to to have very little API churn between SDK versions. And you can rely on the fact that if you don't want to upgrade, your app is still going to stay working for people, and you're not going to be left behind if you choose not to upgrade to the new SDK version for some while. All right, so what else can we do with Exponent and by building apps in pure JavaScript? So we have several native APIs, quite a few actually, such as video, maps, Facebook login, push notification support, camera support, location, permissions control, and several more. And like I said, we're constantly improving or expanding these APIs every release, and we release every month for what it's worth. I know that there's probably some alarm bells going off that are like, well, there's no way you could possibly support every single API that ever exists across both platforms. And the answer to that is you're absolutely right. But we have a different approach because we recognize this problem. And so what we want to do is expose the lowest level native APIs to JavaScript, and sometimes that requires some cleverness, so that like we and you guys as app developers can build pure JavaScript solutions to solve problems quickly, reliably, and with native power without feeling the need to write Objective-C or Java, right? And then in addition, like every API that we expose, we really try to carefully consider how to make it work cross-platform without a bunch of differences, right? We want to enable, where it makes sense, of course, we want to enable a truly kind of write once, run anywhere type of experience. And I think we can do it. And so an example of doing that that we've done so far is with push notifications. So notoriously, like, push notifications can be kind of a pain to set up, especially when you have to do it across more than one platform. And but with Exponent, we're just trying to make it super simple. So you can call this method notifications.getExponent push token async when you start your app, and this will return you this like platform agnostic device token that you can send up to your app's backend for later use. And this function is not different across iOS or Android. You don't have to do anything different. It just works. So from your backend, then once you have this push token, you can call exponent.notify along with some type of device token, along with the device token, and you can, we have SDKs for Node, Python, Ruby, et cetera. And this push notification is going to be seamlessly sent across both platforms. No crazy configuration across both platforms, no push notification certificates to worry about. It just works. So this type of simplicity is not always possible. One thing that comes to mind is that the fingerprint sensor that you find on like my Nexus 5X up here and on iPhones, most iPhones nowadays, there are different features and there are different ways that you can interact with those. And so, sometimes it is necessary to make like a more Android-specific API and a more iOS-specific API. But where we can, we still want to be able to share functionality between those two platforms. Okay, what about like icons, assets, fonts, etc.? So obviously these are super important in any mobile application, right? You don't just have code when you're building a mobile application. A lot of your app, and probably the amount of your app that takes up the most space, is going to be resources of some kind. So we have really tried to make this process like pretty seamless. And so the way that React Native the normal React Native lets you use images is you can actually just require them. Just like you'd require another JavaScript file, you'd say require path to my image, right? And so what we wanted to do was not change that type of developer experience at all because we thought that was pretty good. And so instead what we do is tie into the React Native asset system that is being powered by the packager. And we automatically, statically analyze your code to find those image resource requires. And then we'll take those images or sounds or other custom fonts, and we'll kind of transparently upload those to a CDN. And then when your users open your app, and then they open your app for a second time after you've updated it, rather than resending down all images or all fonts or whatever, you're only pulling down the assets that have changed, which basically makes Exponent in this case work like a typical web app that has like a really good caching policy enabled. But the difference is that with Exponent, you don't have to, as a developer, worry about the asset delivery pipeline. So finally, you built your app, which is cool, and you've sent it to all your beta testers, and they've given it a try, and you're ready to release it to the App Store. So what you just saw happen there is you can just call ext build from the command line, and we'll remotely package your app into a standalone binary and provide you with an IPA or an APK for Android, ready for submission to the Apple App Store or the Google Play Store. There's no worrying, unless you want to, there's no worrying about key stores or provisioning profiles or push notification certificates. We just handle all of that for you. We can take care of all of that so that you essentially just have to hit upload. And I mentioned Windows support before and Linux support. The great part about this is that because we're building the IPA and APK remotely, you can literally go from 0 to having an app, like an iOS app in the App Store by developing your entire thing on Linux, for instance, right? Without having any of the iOS or Android build chain installed. I also want to say that Exponent is completely open source. The client, the Exponent developer environment, the command line tools that we have, any libraries that power those, documentation, as well as all of our native modules are available for your perusal on GitHub. So, it's not a closed source platform by any means. So this might sound cool at first glance, but like, is it good enough to do something besides like build some like simple demo app? That's pretty important. You want to actually be able to make apps that are complex, that serve users, and you want to do that completely in JavaScript, right? That's the point of what I'm trying to talk about. And so I think you can do this. About 6 months ago, we released an app called li.st list to the Google Play Store. This company existed already. They had an iOS app that was very good already in the App Store. And so we were kind of tasked to build an Android version of this. And it's a pretty complex application. It has somewhere around 50,000 lines of code, which is relatively big for a JavaScript application at least. And this is what it looks like. And if you want to, the screen stays on. Okay. If you want to yell at me for having a tab bar at the bottom of the screen on an Android application, trust me, that wasn't my call. That was the designer's call. There's nothing about Exponent that forces you to do that or anything like that. But other than perhaps that little UI feature, I think it definitely feels native. The transitions are fast. The feed is very fast when you scroll through it. Yeah. So I want to talk a little bit about perf, right? If you're building a production application, you need to care about performance. So with React Native in general, the long story short is that perf is very good, and it's getting better all the time. And I want to talk a little bit about like some of the ways that we've investigated like how to continue making performance better in React Native. So your first thought, if you're familiar with like the concept of like a web worker, is that maybe you could use that similar concept. I talked about the threading model before. Maybe you could use that similar concept in React Native. But it turns out, and Facebook has experimented with this a bit, that is really not usually the recipe for success. So even though our newer phones have a lot of RAM, we definitely still have to support people with older Android phones that can be quite a bit more resource constrained. And so every time, if we were doing a web worker type of model, every time we spin up a new JavaScript context, that's going to use more RAM, and we don't want our app to get killed. And what it turns out is that creating these web workers in a React Native type of situation really doesn't add very many speed improvements. So instead, we have two other key places where we found that we can improve performance. So the first one is just do less, and that hopefully makes intuitive sense. The less your application does, the faster it probably will be. Now, of course, I don't mean do less as far as deliver less features to your users. What I mean is being smarter about things like making sure code that doesn't need to be parsed or loaded at a certain time is not happening when it shouldn't be, right? So one of the things that takes the longest when you're running JavaScript at all, remember it's an interpreted language, and so it needs to be parsed by the JavaScript VM, and parsing can take a long time. And so if we can avoid parsing, a megabyte of JavaScript on app startup time, and only parse the JavaScript that we need to load the first screen, we can see really good startup performance. And then second thing is to be creative with scheduling. And by scheduling, I mean scheduling work in your application, such as network requests or data fetching, or even rendering. We want to make sure we're not doing anything non-essential when you shouldn't be, right? And the cool thing is here is that there's definitely takeaways from these two things as an individual app developer that you want to make sure you're writing your application with kind of those things in mind. However, the framework, React Native and Exponent, are able to do a lot of this work for you, so you kind of get a lot of these performance benefits out of the box. And one really good example of that is animations. So animations are something that, rightly so, people are constantly concerned about when they hear me or anybody else speak about writing a mobile app in just JavaScript. iOS is especially known for its smooth, beautiful animations that when you're transitioning between screens or whatever, it's they're used in both the operating system and of course in a lot of the top iOS apps. And it might seem counterintuitive to think that with pure JavaScript we could ever get that type of performance that we get from native world. But in fact, we actually have this interesting opportunity to parallelize work that's happening during animations better in React Native than if you were developing in just native, at least not without a significant amount of work. And so in React Native there is we have an API. It's a pretty cool API. It's called Animated, and it's simple to use. It's declarative, and it lets you define complex animations, including chains of animations, and easily use them to animate different properties of your React components. So up until relatively recently, these animations, as you might expect, they're written in JavaScript, so they were running completely on the JavaScript thread. It's fine for small animations, but if you're transitioning from one screen to another, and you were fetching and processing data, you're demarshaling JSON, and you are also rendering React components, which, as you can imagine, the reconciliation algorithm is happening on the JavaScript thread. You would notice dropped frames because it's also, at the same time that it's doing all the rest of that work, it's also trying to compute at 60 frames a second new values for your animation. And you especially notice this on lower power devices. So the awesome thing about Animated being a declarative API is that we can treat it similar to how we treat React components in React Native, which, as I mentioned earlier, is also a declarative API. So we can define this animation and what we want it to look like and what we want it to do in JavaScript, send that definition over to the native layer, and then let native actually do that work of executing and rendering the animation. So that means that with animated offloading, the animation calculations themselves are happening on the main thread, and which is going to allow that JavaScript thread to casually just chug along and do whatever work it needs to do to render the next part of the screen. And so what that results in, and we use this technique on lists, and if you download it on your Android phone, you can kind of see what I'm talking about. You don't notice any lag between any of the screens. They're you get fully 60 frame per second animations. So that's really cool, but I wouldn't say the work is done on this. There's more things we can do. We do have things like animated.timing, which lets you do like a typical like animation, and we have animated.string. And then just recently, we added we made animated.event, which lets you respond and create an animation based on a gesture or based on scrolling a scroll view, for instance. And we were able to make that offloaded. And so, like an example of that type of animation is if you've used a Twitter app, you know that when you like look at somebody's profile and you pull down on the, at least on iOS, when you pull down on the scroll view, it's going to like enlarge the image and maybe blur it a little bit. And so that's an animation that is directly related to the scroll touch event. And so what would happen before with animated.event is that because we're working in React Native, we'd intercept that touch event. We would send that touch event back to JavaScript. JavaScript would recompute those animation values and then like start the rendering pipeline all over again. So you can imagine that there was at least a frame lag there, and actually especially on lower power devices, there was quite a bit more than a frame lag. And so with offloading this, we no longer have to go back across that bridge. We define what we want that scroll value to do to our animation. We can interpolate over it, whatever. And all of that work gets offloaded and works completely natively. And then another example is one thing we want to be able to do is implement like a loading indicator type of animation. And usually loading indicators loop, and we don't want to make JavaScript handle that looping logic, right? We want that all the rest of the animations are happening, off the JavaScript thread. We'd also want the looping too. So we're exploring like an API such as like animated.loop that would make that possible, and we can offload that. And on a kind of unrelated note to animations, I often get a question about obfuscation and whether or not we do this at Exponent to make it so that somebody can't just download your JavaScript and like see what your app is doing. And the quick answer to that question is no, we don't do that. And we may look at this a little bit more in the future, but honestly, we kind of chose not to do that on purpose. And the reason is that you should think about your pure JavaScript mobile app the same way that you would think about a web app, right? You would, of course, minify the source, right, which we do as well when you publish your app. But you're not going to be like if you're building a web app, you're not going to be encrypting it or anything like that. It's just not practical. And so what this means at the end of the day, I think, is you should just follow the same best practices that you would follow if you were developing a web app, or even if you're developing a fully native app. Like sometimes people forget that native apps in Objective-C or Java can pretty easily be decompiled, and even if they're not fully decompiled, you can run strings on the binary and get API keys or whatever, right? So the key here is don't put secrets in your code. They should never be there, and just make sure you're securing any API endpoints that you might have by using some type of revocable API token. Don't put an app token or something like that is static, that is not revocable in your application. And you should do that on Exponent or anywhere else, to be honest with you, any client-side application. Okay, so everything I've talked about today is possible today. You could go home and you could start doing this, you could start applying these principles. But what I find particularly exciting, and what I want to wrap up with here, is what can possibly be done in the future by following this same, like, build in pure JavaScript and again, like, taking that to extreme. So, you've heard me mention iOS and Android a lot tonight. That's what Exponent supports today. React Native actually has some relatively experimental support for Universal Windows Platform, and even Canonical, who makes Ubuntu, they have built React Native Ubuntu, so you can build Ubuntu applications using the same programming model. And so, like, I think it's really exciting and easy to imagine a world where we can deliver these pure JavaScript applications, probably with large amounts of shared code between them. It's pretty common when you're writing a React Native or Exponent application, a little bit more so with Exponent because of the native APIs that I was talking about, to share maybe 80, 90, possibly even 100% of your code between platforms, depending on what your app is. And so, we have this ability to share code. We can share it across desktops, across game consoles. Remember that Xbox, like, you write apps for Xbox using Universal Windows Platform. Across mobile devices, televisions, so like Apple TV or smart TVs, or smart TVs. And then there's also this possibility of maybe targeting VR, or like with Oculus or HoloLens from Microsoft, which is, it's AR, but you get my point. And I think the possibilities here are really endless. And then another thing that I'm particularly excited about doesn't come from the React Native team at all. It comes from the React team. So remember, we're using an actual version of React. It's not some crazy fork version. It's the same version of React that you use in your web applications. And what they're working on is this really cool thing called React Fiber. And Fiber is this new reconciliation algorithm, which is the core algorithm of React. It's currently in active development. It has not yet been released, and I have no idea when it will be released. But the headline feature here is incremental rendering. And what that means is we will have the ability to split rendering work for your components into chunks and spread it out over multiple frames. You don't have to just call render and then hope that your render pass completes in one frame. You can intelligently, both automatically perhaps by the underlying framework, and then if you have certain custom situations, you as the app developer could decide, okay, well this section of my UI should render with a high priority. It should absolutely be there as soon as the user can see it. And the other part of this screen might be able to wait a few frames, and we can fade it in or something like that. And I really think that's kind of like the key feature to continually building really performant UIs in JavaScript on mobile. We're already in a really good spot, but I think Fiber takes this, potentially takes this just a huge step further. And I think it can solve potentially some of React Native's biggest perf issues today, such as one example of that is list views. Usually, sometimes people have to depending on your app, they have to resort to writing some type of kind of custom list view implementation, which is something we're all actively working on to come up with some silver bullet. But I think that React Fiber can start helping us with those problems. And then probably the thing I'm absolutely most excited about for the future is something we're working on at Exponent. And remember earlier I had mentioned that Exponent wants to expose the lowest level native APIs that it can. It doesn't want to expose a ton of high abstractions. We want a low level API so that we can build more pure JavaScript abstractions on top of it. So one particularly exciting way that we're looking into this right now and experimenting is the ability to write WebGL code in React Native and have this WebGL code executed on the device as if you were writing just pure OpenGL. And so if any of you are familiar with Three.js or Pixie.js, or ReGL. These are some libraries that let you do WebGL stuff on the web. The idea is that you'd be able to use these libraries verbatim directly inside your JavaScript Exponent application. And so your mind probably immediately jumps to games, right? So we could write like 2D or 3D games this way. That should be very, very performant. But the other kind of interesting opportunity is if you were building like the next Snapchat and you needed to do facial recognition or whatever, generally, I'm simplifying a little bit, but generally the way that would work is it's going to use the GPU to do a lot of that calculation. And so there would be nothing stopping you with this approach in writing some compute shader that can give you certain information about, or I guess the first thing you would do is load the video texture from the camera into WebGL, be able to use a compute shader to analyze that texture, and then you could get that data back out and use that data in your JavaScript application. No native code required. And I think it's in the very early days of experimentation. We do have more or less a working prototype, but we're still kind of battle testing it, and I don't really know when we're going to release this yet. But I'm really, really excited about the future of this feature. I think it opens up a lot of interesting possibilities. And I should note too, we want to make sure we expose some type of audio API, probably very similar to the web audio API, to let you do just as much power as you have for the graphics. You could have that same power for audio. And then I've spent an hour now talking about writing an app in pure JavaScript, but I'm really passionate about it, but I wouldn't be doing my due diligence if I didn't mention that, at least today, in certain cases, there definitely is going to be a need for your application to write native code for a certain part of your application. I hope that it doesn't come to that for you, and like I said, most applications probably will not have to do this, but it's definitely a possibility. And we realize that, we're realists, right? We realize that Exponent is relatively new, that we don't have every low-level native API exposed, and yeah, we can't just fulfill every need today. Hopefully we will be able to in the future. So what we're currently working on is a relatively simple solution to let you detach from this pure JavaScript Exponent. And at a high level, the way this is going to work is that it will create an Xcode and an Android Studio project, but instead of taking you back down to fully vanilla React Native, we're going to have something called Exponent View that is going to be running your Exponent app inside of it. And so, but the key difference here is that you can then add native modules to this application, and those will be exposed in your Exponent View if that's what you need. And the chances are pretty high so as an example, one thing we don't support today, although we will be supporting it very, very soon, is Bluetooth capability, which obviously is super important for mobile, right? So say you wanted to, you needed some Bluetooth ability in your app, and you needed to detach from Exponent and use some native module and expose that up to JavaScript. Well, the thing about this is that we're going to add that Bluetooth ability back. And when that happens, you would just very easily be able to switch back to using Exponent and still get these benefits of continually deploying your code, et cetera, and without having to do any rewrite or whatever. And so the key here is that we're not trying to lock you into the platform. We want you to be able to escape if you need to, but that hopefully over time, it becomes less and less important and less needed to do this in certain cases. So that's kind of our goal. So just to recap a little bit, what building native apps in pure JavaScript can provide to you is a much better developer experience than building a traditional native app. You get this faster feedback loop, both while you're developing and then also being able to deploy your code to your users quicker and getting feedback from them. You can share a lot of code between both platforms, potentially all of your code between both platforms. And all at the same time, you don't have any user experience sacrifices because you're still rendering native views and not using web views and things like that. There is no emulation going on here. So give it a try. Do it with a demo project. Come talk to us on our Exponent Slack, and maybe do it for something more serious than a demo project. All this stuff is possible today. Well, everything that wasn't after the hashtag the future slide, and the developer experience is pretty great. So thank you.
Thank you so much, Adam. Any questions? Otázky?
Question.
How does this make money?
Good question. Good question. Right now, so I mentioned like everything is open source and our service is free. The long story short is that right now we're not focused on making money, and that's actually okay because you guys might know that if you're in Silicon Valley, like you don't have to make money. But in all seriousness, even though we're not focused on making money today, you're right, we'll have to make money eventually in the future. There's a couple possibilities for that, but we don't know exactly what the one we'll choose might be. It could be offering some type of service layer, right? So you can imagine we offer like analytics or something like that we would need to charge for. I talk about push notifications. So if you come onto our platform and you have a really, really popular app and you start sending millions and millions of push notifications every hour, we probably need to come up with some way to charge you for that, just at the very least to cover some server costs, things like that. The other thing is, as we get more developers building on our platform, if we're helping you guys as app developers make money, there's a pretty good chance that we can come up with a way to also make money. It could be something similar to what Apple does by taking some type of revenue from push notification, from in-app purchases. Who knows? These are all possibilities that we're really just not focused on today because, to be honest, like what we're really trying to do here is change how people think about mobile development, and then maybe years from now, and when people actually like building things this way, we can come up with some novel approach to making money. But the main focus is, and the thing we all care the most about at Exponent is just making mobile development simpler, easier to get started, and just kind of letting you do some of the awesome things that I was talking about, and that's really our only focus.
So, talking about the code sharing between the iOS and Android, for the application you mentioned the list. How much was it for the real application?
Oh, that's a great question, and I should have been clear on that. So in that particular case, and this wasn't out of necessity from our platform or anything, but in that particular case, we only built the app for Android because they already had an iOS app. However, I can give another example, which is that, for instance, like the Facebook Ads Manager application, which you may or may not be familiar with. It's kind of a separate application from the main Facebook app. That is written completely in React Native and is fully cross-platform. They share about 85% of their code between iOS and Android, and that number is actually going up over time as more things are bridged between. And some other people that have built applications on Exponent have seen 90 to 100% code reuse in real production applications. So it really depends on your use case. I can't guarantee you'll be able to share 100, which is probably okay. One of the powerful pieces of this is that if you do, there are platform differences, right? We don't want to say that you shouldn't care about platform differences. And so there are going to be use cases where you want to have a different experience on iOS versus Android or whatever, right? And so we want to give you that ability to do that. So we like to tout that you can write it 100%, But the reality is that, perhaps for your application, 85% or 90% or whatever is the right number.
Any question?
Sure.
How big is your team at Exponent, and how many are the contributors of the open source?
Sure. So it's a great question. So we're pretty new. We were in this startup accelerator called Y Combinator that just ended back in mid-August. We have 7 people, so we're a really small team right now, although we're quickly growing. So I hope to be, I probably shouldn't say this out loud, but I hope to be double that or so by the end of the year.
Any other open source contributors?
Yeah, so 3 of our team members, myself included, are React Native contributors, right? Core React Native contributors, so we're on the core team. And so we are kind of like constantly in touch with the things that Facebook is doing with React Native. So that I think gives us a bit of a leg up from like even just our small team to be able to do some of the stuff we're talking about. And then regarding open source, we actually just open sourced it maybe like 3 weeks ago or so. So the number of open source contributors is not very high. We do get, we definitely have quite a few open source contributors on some of our other projects, some of our like libraries that we have open source on that are built on top of Exponent. We have a few here and there that contribute back to XDE, but I would love to see more. Like, I think that there's a huge opportunity for people to come and help us build this platform. So I would hope that we can get more people pretty soon. But yeah, so the answer is small at the moment, but just probably hopefully more of a factor of time than anything else.
If you want to join, have a talk.
That's right. Any other questions? Over there.
Have you tried native script, and how did you compare that to React Native?
Sure, great question. So I have played around with native script a little bit. I've not built a production app in it. And I think their model is pretty interesting, but I do want to say that I think it's fundamentally different. So one thing from a technical perspective that I talked about in my presentation was the async bridge that React Native has. Well, the way native script works, and unless they change this in some way, the way it works is it is a synchronous bridge. And it kind of has to be because of the way that NativeScript has structured their APIs, right? They've structured their APIs basically exactly mimicking iOS APIs and Android APIs, right? And so that means that like, if you want to open an iOS alert view, for instance, you are opening that by calling like UI alert view .present or something. Don't quote me on that. But it's that type of API, right? So it's this imperative API that like if you want that, they can't really, with that idea, they can't really apply this kind of batching mechanism, because you would expect, I think as a developer, that when you call UI alert view.present, it's going to present immediately. It's not going to wait a frame or potentially multiple frames if you have other work going on. It's going to present immediately. Versus the React Native and Exponent model, where you are using React components, which predefine what your, and then are basically functions of props and state for what you want your layout and your views to look like. That means that they can be transformed into real native views at any time. So that's kind of the fundamental difference. It really is, generally doing the same thing. There are a lot of similarities, but it's just a completely different approach, right? And I do think that some of the problems that I mentioned about relying on like single-threaded JavaScript or whatever can still apply there, or can definitely apply to NativeScript, given that say you're doing a bunch of work and you want to like in your JavaScript thread, like kind of like I don't know, fetching or rendering data or whatever, and you want to display some alert. Well, if the JavaScript thread is like kind of lagging behind sometimes, or if you're like waiting on a network request or something like that, your alert view is like not going to open. And so unless you could probably start to work around some of those issues. But yeah, and I know that NativeScript has been around for a long time, certainly longer than React Native, and it does have a pretty big community around it, but I haven't seen any like large companies or anything working with it. And maybe you think that doesn't matter, but I think there actually is a lot of value to having larger companies with larger engineering teams kind of investing in these technologies. So for example, with React Native, yeah, you have Facebook, but there's several others as well. There's Airbnb, Twitter is doing some stuff with it, Uber. You know, those teams are all contributing back, and I think that's super valuable. So to summarize, I'd say, you know, underlying architecture, the way that they've decided to, so number one, underlying architecture, number two, the way that they've decided to structure their APIs, and then number three, I think even if our community isn't necessarily bigger, although I think it is, because we have like 30, like on the React Native repo, there's like, it's like 40,000 GitHub stars or something like that, and we have over 500 open source contributors to React Native. So that kind of goes a little bit back, at least, even if Exponent doesn't have a lot of open source contributors yet, React Native certainly does. And yeah, so community, I would say is something that's different as well. Does that answer your question?
Yeah.
Great, thanks. Any other questions?
Okay, or maybe if we will move to that 1-2 bar and we can talk and discuss things, having beer and much more better.
Beer sounds good.
So, takže ďakujem za účasť, pozerám všetkých na pivo, do toho baru 1-2.